Hi everyone, in this video I'm going to go over our notes 6.2. What you need to do is just watch this video, take notes, and then complete the homework assignment on 6.2. And as you know, everything is posted on Office 365. Here are my expectations. There's another video that I posted on how to find the confidence interval of the proportion using the calculator. Just in case my video wasn't thorough enough, I want to make sure you have a nice video on the calculator commands. As for the calculator, there were a few apps that I listed, and there's also the free download. You can also download the Tiny Scanner app, which will help you scan in your documents after you completed those. I also included the PowerPoint down here so you can download that, print it out, and take notes along with the video. Something else that might be helpful is up here on Files, if you select Stats Materials, I listed out the reference sheet. And there are a lot of helpful things on here, like formulas and calculator commands. But before we start, I just want to make sure that you are all doing good. I really miss you. Mrs. Johnson and I are over here doing our best to help you with the material. But again, if you have any questions at any time, please reach out anyway to some people were messaging me through the chat on 365 to get help. Some people were messaging me on Remind. And when you submit your assignments, I'm making comments and corrections. So you're getting your full credit, but I'm leaving those comments to make sure you fully understand the material. And if you are not getting it at all, just again, please reach out. We're more than happy to help at any time. Yeah, so let's get started with our 6.2 notes. All right, so in this video, we're going to be talking about how to calculate the confidence interval for a single proportion. We've talked a lot about confidence intervals before. We could have a 90% confidence interval, 95, and so on. And just to jump to the summary, the whole point of this is to figure out, or come up with this saying, we are 99% sure that the proportion of blank is between blank and blank. So that's the whole goal of your confidence interval. You're finding where that true proportion lies. Okay, so for the outline, we can calculate this by hand or using the calculator, and I'm also going to talk a little bit about margin of error in this video. So within our formula, we're going to be dealing with our p hat, and I just want to make sure that we're clear on the difference between p and p hat. So here's this little section of notes. P measures the percentage of the entire population, and then p hat measures the share of a random sample in the population. And p hat is represented by P with this little symbol right above it. So the first part in figuring out the confidence interval for this is to calculate your standard error for p hat. And this is our formula, except we don't know what p is, meaning we don't know what the percentages for the entire population. So what we're going to do is we're just going to substitute our p hat, which will be given, and that's going to be our best guess for p. So we're going to take that standard error, and that's going to be integrated within the confidence interval formula, which is right here. You're going to take your statistics. It's going to be your statistic. It's going to be plus or minus the z, which is our z-score, at a 90% confidence interval, 95, 99, whatever. And you're going to multiply that by the standard error. So again, that translates down here. Your standard error is right here. And again, we're just multiplying by our z plus or minus. Our statistic is now labeled as our p hat. And right here, these are just a few constraints that we need to make sure are going on before we perform this confidence interval. But for the most part, For all of your homework assignment questions, they're all, that constraint is checked off for every single problem. And when it comes to this Z right here, it's a standard number for whatever confidence level you are set at. And these are the values of our Z scores. So if it's a 90% confidence interval you're calculating, the number for your Z is 1.645. And these values are on that reference sheet that I showed you in the beginning of this video. Okay, enough talking and let's get into an example here. So the first example is about sin taxes. And this is just a tax on items considered undesirable or harmful, such as alcohol or tobacco. So in March 2011, a random sample of 1,000 US adults were asked, do you favor or oppose sin taxes on soda and junk food? 320 adults responded in favor of sin taxes. We have a 95% confidence interval for the proportion of all US adults that favor these taxes. So we have 1,000 adults that participated and 320 adults responded, and there's a 95% confidence interval we need to calculate. So the constraint is checked off, so we can move on. Now this is how we're going to calculate it by hand. Again, same formula is right here. We're just going to plug in our values. So we need to calculate our p hat. Now that's just our 320 out of our 1,000. Get that down here, which is going to give us 0.32. Then we need our sample size, which was 1,000. And we need our Z value for a 95% confidence interval, which is here. And that number is what was located in that chart. So these are our values that we are going to plug into our formula. All right, so there's our p hat, our Z, p hat, and our n. And you get your values here. You just simplify the one side. I would simplify what's under here, take the square root, then multiply. Right here, they're then multiplying that, and then they get their interval. Now, an interval is a number from a minimum to a maximum. So this number right here is your minimum, and the next number is your maximum. Make sure that you put the smaller number first. All right, now we need to make sense. What do these numbers actually mean? So if we're taking a look at this as a whole, all of these dots represent the entire sample, which was 1,000. All right, there's 1,000. And then here's our confidence interval right down here. So we need to make a statement. This is our key phrase here. We are 95% confident that between 29.1% and 34.9% of all US adults favor sin taxes on soda and junk food. So you can do it by hand, or you can, what's in this picture here is using StatKey, which is that online resource we've used before, or you could just use your calculator. So these are the commands for the calculator. It's actually pretty simple. So you just go to Stat and then over to the right to Tests. And then you need to go all the way down to A, which is 1 proportion Z interval. Not Z test, we need the interval because our confidence interval is our interval. Then the numbers that you need to plug in are going to be X, N, and whatever confidence level you're going to be set at. So starting with X, that's the number of successes. So for this random sample and the question here, the number of successes is going to be this 320, right? So X equals 320. Notice we're not using the proportion. Okay, so this was our p hat from when we used the formula, but we do not want this number here. We just want the 320. That's your X. And then we need our N, which is our total number of samples. So n is 1,000. And then our confidence interval, 95. CI confidence interval. Okay, and for this, we do not need that Z value. It's already put into the calculator for us right when we click on whatever interval level we want. All right, and then when you hit enter, you get that min-max number. So here they are. And then again, you want to write that statement out. All right, and then notice that we do change from the decimal and we multiply by 100 to get our 29.1% and our 34.9%. Okay, so that's how you would do it using the calculator. Very simple. The tricky part I would say is just making sure that you take the x and not the p hat. The last thing, your homework in example 2 asks you to find the margin of error. Now the margin of error is just basically integrated into that confidence interval formula. So this is the formula right here for margin of error. It's just the z-score times the square root of p hat and all that jazz. So you do need the z-score for this. So I definitely recommend going back to the reference sheet on Office 365 or just rewinding this video and going back a little bit to the slide that had all of the z-scores on there. All right, so if you calculated the question by hand for example 1, you already have most of the answer for example 2 because it's within it. So here's the confidence interval formula that we just worked with, and it's right in there. So these are the same thing, this, and this. So if you have it all calculated out, you only need this number here to the right, and you just calculate that out, and that is the actual margin of error. So for that example there, the margin of error, ME, equals 0.0294. Okay, that about wraps it up for this video. Here's a little bit of a summary. So what you just did was you found the confidence interval for a single proportion, and then we did a little bit with margin of error too. Your results are always going to go from min to max, so your lower limit to your upper limit, depending on your confidence level. Proportions could be percentages, decimals, or fractions. Just be careful when you're representing those in the calculator or doing it by hand. And those are the two ways that we can do it. And make sure to always write a conclusion statement. And that does it for this video. Good luck. You can do it. If you have any questions, please send me a text through Remind, email me, chat me on Office 365. Whatever you need, I'm here for you, even though I'm far away in my house, working from home, while my husband is too. And if you heard anything, it was him upstairs. He's got this rolly chair, just making so much noise. And he kind of distracts me while I make these videos. So anyway, good luck with the assignment. I'm going to make the other videos and they'll be posted shortly. All right, have a great